Hi, everybody. Good morning and welcome to another amazing session today.
Good morning.
I'm happy to be talking to you this morning as we engage further on the aspects of green. Many people think green in different areas. Many people think green in different formats. But what we're doing here is to ensure that we're able to have all the blend of people from all walks of life, understanding and appreciating things that are very interesting. So today, as we open up the second session of Green, first and foremost, I just want to have a minute silent for all those who have contributed very actively to the Green movement and perhaps are not with us anymore, but also for people who through the COVID pandemic have lost their lives and any other person you know. I just want us to have that moment of reflection as we start this session today. So from wherever you are joining us, please just have a moment of silence as we acknowledge these persons. May their souls rest in peace. So my name is Enoch Yeboah Ejepong. I'm an engineer and a development consultant. I've worked in the space for quite a number of years now, at least 15 years and counting. And I'm happy for all the changes that are happening. I know that you out there somewhere are also thinking of various innovative ways of moving things forward. And so I'm excited, extremely excited that we are joined here together. And as I pace around and reflect and think about the amazing things we have ongoing, I'd want you to also think and reflect more personally about what you bring to the discourse. It shouldn't be one that is lopsided. It shouldn't be one that is skewed, but it should be one that is all involving because we want to move away from just talk and move more into practice. And for that reason, I'm happy to bring on board the first set of panelists who are going to have a very engaging time to think about the issues around emerging innovative technologies that are enabling energy efficiency and renewable energies. And this is the Game Changer session. And this being the Game Changer session would have four persons who are going to join me in this conversation. There's Jibril, there's Nana, there's Mark, and there's Kenneth. And so in order of the names mentioned, I'd want these persons to introduce themselves much more crisply so you can know them better. Jibril, take it away.
Good morning, everyone. Good morning. My name is Jubril Adiojo, the co-founder and CEO of One Solar, based here in Lagos, Nigeria. And I look forward to this conversation. Thank you.
Thank you very much, Jibril. Nana.
So my name is Nana Iwabotiai, Ghanaian, residing in Brisbane, Australia. The Global Green Tag EPD Program Manager, and we pretty much work within the built environment in terms of certification and assessment for a lot of the green building industry, most of the green building assessment and industry practices around here. And I'm looking forward to the discussion, and I'll just pass it on to, I believe, Mark to introduce himself. Yeah.
Hi everyone, my name is Mark, and I'm a researcher at the Renewable Energy Research Group in Hong Kong Polytechnic University. So I basically work around life cycle assessment with sustainable building designs and renewable energy integrations. I look forward to interacting with you all. Thank you. Over to you, Kenneth.
Okay. Hi everyone. I'm Kenneth Apia Donko Shiaman. I'm a lecturer at the Kwame Nkrumah University of Science and Technology, and I teach and research about sustainability and finance. Yeah.
Okay, so thank you very much, and you're all welcome. What we'll do right now is we'll go into a presentation session where Kenneth is going to start off, and then in the next 5 minutes, we're going to listen with rapt attention. Please note down your questions. If you have any questions you want to pass on, please type it in the chat box or anywhere else. And then we would have a good dialogue subsequently. Kenneth, please take it away.
Okay, thank you, Enoch. I'll just want to provide some highlights of a study we are currently conducting. And it's on green building technology literacy and housing choice. And my presentation will touch on three main things. I'll just talk a little bit about the problem we are trying to study. And then I would also look at the survey we conducted, and then I'll present the results. And so whether we are talking about harnessing wave power by CETO systems through the use of underwater buoys to convert sea waves into zero emission energy in Australia, or rain or shine, new solar cells are able to capture energy from raindrops in China, or new solar panel design using the mineral perovskite as a flexible and efficient mineral enables the use of sunlight to produce liquid and gas fuels, or the use of bionic leaf to turn sunlight into liquid fuels in the US, or the generation of solar energy through bacteria-powered bio-solar panels, or even the harnessing of typhoons using turbines in into wind energy in Japan. A fundamental problem remains that the adoption of these technologies is influenced by the knowledge people have of them. Unfortunately, many people are not aware or are illiterate about these renewable energy innovations, according to the literature. So, it's interesting that the youth are the future of the world, and yet scholars show that youth education and engagement on climate change mitigation and energy efficiency strategies have been insufficiently addressed. And so in this paper, we engaged 736 Ghanaian youth, precisely university students, to learn about their level of green building and green building technology literacy, and also examine how green building technology literacy levels affect their housing choices. So I will talk about the results and then I'll end. So we asked a very simple question to know about the awareness of green buildings. And here we asked them, have you ever heard of green buildings or green building technologies before? Interestingly, out of a sample of 736, 57% of them said no. Only 43% of them had said yes. Now you realize that a yes or a no answer is just inadequate to assess the level of knowledge of people about green buildings. And so we went on to ask a second question, which allowed them to rank their level of knowledge on a 5-point rank scale. And here, the results show that the majority of the students we surveyed, constitution about 43% of them, said they had no knowledge of green buildings. And about 36 of them had indicated that they have basic or fundamental knowledge about green buildings. Altogether, about 80% of the sample had indicated that they had no knowledge to basic knowledge in green buildings. Now, it is quite well established that usually people are overconfident about their about the knowledge of themselves. And so we believe that at some point in time, some people would choose or would indicate that they have knowledge about green buildings when they didn't, or they do not have knowledge about green buildings. And so we conducted a test on green buildings by giving them 9 true statements for them to rank on a 5-point Likert scale. So 1 represented strongly disagree, 2 represented disagree, 3 means I don't know, 4 means agree, and 5 means strongly agree. Sorry about that. And interestingly, because these statements are true statements, our expectation was that any student who knew about green buildings or green building technology would choose or would agree or would strongly agree. And so we expected that the average score should be around 4, between 4 and 5. Unfortunately, the mean scores which were computed show that most of this, I mean, the average scores were below the 4 to 5% expectation we're looking at. And this continues to highlight the fact that most of the people we are surveyed knew nothing about green buildings. Now, we went on to look at their housing choices because we believe that knowledge could impact on their demand for different types of houses. And here we were interested in knowing if they have previously lived in a house that had green features. Okay, here we are not measuring whether they have lived in green buildings before, because that data did not exist. But then if they have lived in buildings that had green features, and these were the features we had shown them in the green building literacy test. Okay, and interestingly, it turns out that about 56% of them had said that the buildings they had lived in previously did not have these green building features. And currently, about 66% of them said they did not, the buildings they live in do not have these green building features. Now, we're also interested in understanding from the perspective of the students, if they would prefer those features, green building features we have shown them. And overwhelming 78% of them indicated that yes, they would want to live in such a house. Now that we've been able to establish the green building literacy levels of these students and their housing choices, both in terms of the houses they've lived in before and the current houses they are living in and the ones they would prefer in the future, we sought to look at examining the relationship between these two features. And interestingly, it turns out that a student who has previously lived in a house with green building features had higher levels of green building knowledge or green building technology knowledge. And it also turned out that the green building, students who scored higher on the green building test scores also were more likely to live in a building that had green building features. And in the future, it is also the case that students who scored higher on the test were students who were more likely to say that they prefer to live in a green building in the future. So what were the conclusions of our study? Our study suggests that most university students in Ghana have no to basic knowledge in green building technologies. And this no knowledge of green building literacy can be attributed to their demographic features. So in terms of age, we find that older students tend to have more knowledge about green buildings. Males tend to have more knowledge about green buildings, and students who were higher, for example, postgraduate students tend to have higher, more knowledge about green buildings than undergraduates. And then people who were employed and had higher incomes also tend to have higher knowledge about green buildings than those who were unemployed and had lower incomes. Now, a key part of our finding was that green building technology literacy levels are related to future housing preferences. And so policy-wise, we believe that educating the youth about green building technologies can alter their housing outcomes and preferences in favor of sustainable ones, and hence contribute to achieving Sustainable Development Goal 11, which is sustainable cities and communities. Thank you.
Well, thank you very much, Ken. I'm interested in taking a bit of a diversion from where you presented to confirm also from Jibril, whether in your experiences, this kind of results that is coming from Kenneth's study also shows true from your engagement. So Jibril, if you want to just touch a bit on at least the demography issues and whether people are more akin to appreciating green buildings and others when they have had such experiences as Kenneth mentioned.
Thank you so much for that question. And Kenneth, fantastic presentation. Green economy, green solution, climate innovations is still at the nascent stage on the continent, particularly in West Africa, right? And even regarding renewable energy. So, and this kind of research study and engagement is is encouraging, and we should continue to do so. What I know for a fact is that people like to live in a very serene and quiet and eco-friendly environment. So people might not necessarily know that that also qualifies as green. And I think we also have to be careful on the volume, or the load of information we try to share with people that are just getting to know this for the first time. So we should ask ourselves, if a house is powered by solar, is that a green building? Is the water efficiency, if the wastewater is being recycled, does that also qualify under green building? Is the color of the building important? So I think we just have to try to layer them very carefully so that we are sure that everybody understands each layer before we now add more layers to it. That's my own experience in the market, talking to various players and consumers, regardless of the demographic. They want to understand it bit by piece, they're not as informed as people like us that understand they understand the goal and the modalities of green economy and climate innovation. But for them, it needs to be layer by layer, and then try to cite some real life examples of what has been done.
Yeah, so Jibril, taking you further on that tangent of real life examples, like I said earlier in the opening, sometimes people don't appreciate what green really is. And so it'll be important for us to be able to also highlight some of the very, very practical aspects of green. So maybe from your work and from how you've engaged, if you can just speak to it in the next couple of minutes, some of the very practical things that are emerging as innovative technologies in the green space.
Thank you. For me, we play very strongly in the renewable energy space, okay? And that has been around the continent for more than 15 years, 22 decades. The take-up is encouraging. So what we essentially understand is that, most consumers of energy don't necessarily care about where the energy is coming from, to be frank, okay? What they just want is 24-hour energy affordable. So it's now for us, players in the market, investors in the market, to find a way to deploy these technologies to be more cost efficient and also at a very rapid pace. So at One Watt Solar, what we essentially do is that we aggregate assets. So we partner with solar companies on the continent. So we're like an Uber in the sense of energy sector on the continent. So we partner with solar companies on the continent, and we appoint them as our partner to do the installation. And we also keep them into the transaction as the operating and maintenance partners too. So what we essentially do is to raise capital, invest in the very best hardware technology, the lithium-ion battery, hardware, hybrid inverters, solar panels, and then customers enjoy the service. So there are two kinds of products we have for the particular market. So we have the one that's for commercial, for C&I, for commercial and industries, whereby they can pay for the power as they consume. They don't want to have to take care of the capex, whereby they have to go and borrow money, or from the balance sheet having to buy the assets. So we take care of that for them. They completely outsource that power to us. We also have some small businesses and homes, particularly in Kenya and Ghana right now, that there's power in the country, from the grid, from the utility, but the tariff is quite high. So we have a lot of customers from that market opting for our lease to own product. You can buy now, pay later, over 3 to 5 years. That brings down their cost of energy because they can either buy the panels or buy the inverters or buy the batteries. So that is what we try to do. And by offering that kind of products, they're able to cut down on the energy cost and also reduce the carbon footprint as well, because a lot of us have fossil fuel power generators that we rely on heavily. So that is how we do. And furthermore, we also partner strongly with a lot of training institutes on the continent, institutes that train young people, male and female, on how to install solar panels, how to install batteries, how to maintain all these things. That also gives opportunity to create new green jobs, sustainable jobs, and also to promote youth participation in how we power Africa in a sustainable manner. Thank you.
Right. Jibril, I'm still staying with you for one particular reason. Nigeria is noted to be huge on oil cartels and oil in general. So if we are talking about the fact that RE is still nascent there, and the off-grid solutions, all the other positives that can come with RE, why are we still in the state in which we are? Is it that adoption of the technology is not coming as rife as it is, or there's no funding to push it out, or there are people holding us back a bit? What's really happening?
Okay, so I'll be careful so I don't get into trouble. I think, and that is why I always advocate for private sector involvement. Okay, and because but the more we rely on the government to take charge of all these essential services, the more we are subject to a lot of politics and bureaucracies and vested interest. So I always say power generation, it is not rocket science, to be honest with you. I can put solar on my roof in the office and I have power. Okay, so what we're doing now, the conversation we're having with the government is to say, what, let people generate that power. Everybody's already generating that power anyway with the fossil fuel generators. So what we are just doing is to rely on that existing market dynamics and to provide the renewable energy technologies to the consumers to generate cheaper power and a cleaner power source. And also, but the main thing though is that the government essentially in the country, they don't work as if they see the power sector as the entitlement to own and control, even if we've privatized some of the aspect in the sector, right? So they don't put the interest of the consumers, the people at hand, at heart, So and that has really affected the delivery of power to people, and that's why a lot of us now just rely on our decentralized generators to sustain ourselves. So what we are doing is to break into that opportunity and get people to subscribe to solar energy, okay, either by buying now, pay later, or by subscribing to pay as power as a service, which is cheaper for them as well. So that's what we're trying to do. We raise a long-term capital to make that happen.
Right. Okay. So with that said, I've just been doing this duo with Kenneth and Jubril, because Kenneth, the question that will come to you later for you to answer is, where therefore do you see the game-changing activities really happening within the renewable energy and energy efficiency space? But before you go to answer that, Nana, you're joining us from Australia, correct?
Yes, Enoch.
And what time is it there now?
It's a little past 8 at the moment on a Friday night. Yeah.
Okay. Well, so that's how it is. I actually decided to bring in the dynamics because we are joined by people all over the world, and we are still at the Ghana Green Building Summit. We're on day 2, and the panel that is currently speaking is talking about emerging innovative technologies enabling energy efficiency and renewable energy technologies. And this is the game changer session. So we have different people from around the world speaking to this. And so Nana, as you take on the floor now, I just want you to also share from your side your key inputs into the subject matter. Please take it away.
I thought it was very important that Jibril mentioned the different business models for different customers, because from my opinion, from my experience, the way to get RE across the continent, to get it to people, is to tailor payment systems for different people from different income groups, right? The government can only do its part, and like he mentioned once again, there is a lot of politics. There is quite a lot of politics when it comes to energy. But what we also do realize is that without energy, development stalls, right? So to be able to, and there are instances where you, in a village somewhere in Africa, the moment energy shows up, the level of income for the people picks up. Right. So for RE uptake, a lot of work has been done, and a lot of conclusions have shown that, especially for Africa, where there isn't a strong framework for support from the government, it is always up to the private sector to be able to develop, to build different business models for different income groups. And that is where we will succeed.
Well, good inputs there. I think what's increasingly happening is that you have the desire to ensure that renewable energy technologies are out there. But then you also have the desire to ensure that energy efficiency measures are done in a way that truly enhances all the aspects of innovation that should come through. It's very relevant, helpful, and interesting to note that to a large extent, people sometimes mix what should happen and are not sure which actors should take the lead in all of this. I think that as we keep on with the conversation, we would continue to sort of elicit and understand where the clear gaps are, what is happening in terms of what's trending, and then activities and actions that should happen with it. So I want you to keep that in your at the back of your heads as we continue to engage. So Nana, thanks for that input as well. And I appreciate that to a large extent, that gap that is prevalent needs to be bridged so that you have a good private sector and public sector engagement to help move it forward. Maybe what you can help me with here, at least in terms of the global dynamics as well, is that how is that seen in Australia? How do you have the private and public sector dialoguing and engaging to help move this agenda forward?
Out here, there is quite a synergy between the private and the public sector, whereby there are programs set out by the different federal governments, which encourages individuals to actually go for renewable energies, especially when we talk about the residential side of it. Commercially, when organizations go for renewable energies, there is a lot of incentives to encourage them to do that, right? In the developing world side, I know there's quite a lot of work being done around policies and programs by the government and all that, but it's still very much in infancy, pretty much copying from what has been done in Europe, in Germany and all that, right? And this is what is happening here, where here the government plays a role in its programs that it sets out, where people, if you get rebates for going for renewable energy. So this encourages individuals to actually go for them, and their benefits that they get from being able to feed into the grid. And this also comes back to infrastructure development also. There is that much support that you can feed into the grid, right? If you produce more than what you can use, right? And you get paid back, right? For what you fed into the grid. And this is once again an example of a strong framework. There's a backbone supporting the uptake of renewable energy.
Yeah, it's interesting you say, because here in Ghana, there's a lot of discussions about net metering and ensuring that you can have the utility appreciate and understand exactly what type of ratio to use, whether 1-to-1 or whichever part. But then there's also the talk about the stranded assets that the utilities would be faced with, particularly if the uptake of renewable energy is much more entrenched. But I would say that in all of these, the conversations have moved quite gradually, although at quite a snail pace, but it's gaining the attention of all actors. And I can see that the regulators, both the energy, the economic regulator, that's the PURC, Public Utilities Regulatory Commission, and the technical regulator, the Energy Commission of Ghana, are all engaging the actors to sort of consider these incentives and these schemes, because at the end of the day, it's when you have such confidence in the sector that you can have people actually going ahead and making renewable energy what it ought to be. Because I've personally always had this concern that why do we live in a very tropical environment where you have abundance of sun, abundance of resources to use, but we're still struggling and grappling with all these issues? I think maybe it's just about cross-fertilizing the ideas when it should come, and then picking and choosing what's adaptable. So thanks for your inputs, Nana. I'll take it on further and go now on to Mark. Mark, you've paid rapt attention to all these discussions, and for you also in the research space, and joining us from Hong Kong, correct? Correct. Okay.
Yeah.
I'd want you to share a few more perspectives on what's been said so far before you go into your presentation, which I know you have. So first and foremost, from what's been said so far, just share a few insights. And again, my standard question: what time is it where you are?
It's past 6:34 p.m.
Okay.
Yeah.
Right.
So thank you very much for the other panelists who touched a lot on their renewable energy aspects. I also like to touch on the building efficiency itself. You know, the very starting point for building efficiency is the design. So it starts right from the architects, right from the builders, the constructors. In Ghana, it's common that a little effort is little attention is paid to the designing of the building, but there are several factors or several design strategies that when you consider the early design stage of the building, we can effectively reduce the energy consumption of the building. Some of them include shading the windows. Some of them include changing the window itself, like double glazed windows, which reduce the heat gains into the building. Then you reduce the energy consumption of the building. There are other things as simple as the orientation of the building and the ratio of the width to the length of the building itself. If, for example, a major part of the building is facing the sun, what it means is that there will be a lot of heat gains. And if there are a lot of heat gains, you spend more on cooling the building and you lose more money. And so all of these design factors, when they are considered robustly at the early design stage, we can reduce the energy efficiency. We can improve the energy efficiency of the building. Thereafter, then we integrate this renewable energy applications like my other panelists shared into the building to cater for it, and we move towards a net zero or nearly zero energy building. And all of this also have implications for carbon emission. The global goal is to reduce it. So as we improve the energy efficiency, as we integrate renewable energy applications, we move towards reducing carbon emissions.
Right, Mark, you just actually struck a chord in my heart. the fact about ensuring that you can have energy efficiency measures being strongly done, and then also the design part, ensuring that from the beginning is done. Last year at the summit, a session I was in was talking a lot more about retrofitting, and that's when you have already done that. So I just want to encourage others who perhaps have also not looked at those publications that were made about retrofitting, that you can go back to the previous year's summit and see information from there as we build on. This is the fourth Ghana Green Building Summit. And like I said earlier, we are focusing on this particular session right now on the game changers, looking at innovative solutions to the renewable energy and energy efficiency space. And the panel currently is focusing on these deliberations. And Mark is going to take us through a presentation from which we would continue. But I want to encourage you out there that if you have questions, if you have information you'd want to share, please go ahead, put it in the chat box, put it in the YouTube space comment area, and you can take it on. Mark, if you're ready with your presentation, you can please go ahead and share.
Thank you very much once again. Share my slides in a second. Can you see my slides?
Absolutely, take it on.
Very well. So in my presentation, I'll be talking about practical ways to reduce the energy consumption of buildings and also some integration of photovoltaic to generate power. So in Ghana, like from this chart, we can see majority of energy consumption can be attributed to the residential sector. This is illustrated in the light blue part, over 40%. And for this energy consumption, it includes energy use at different life cycle stages of the building, like the operation stage, which is the focus of our summit this year. But there are other energy consumption in demolishing the building and recycling, extraction, manufacturing as well. But mainly for the operational stage, we account for about 80% of the energy used in the building. It is due to one, cooling, like air conditioning, and then secondly, lighting, like the regular lights used in the building. And then thirdly, the equipment. Those are like internal plug loads, like appliances, refrigerators, and fridge TVs, and the likes. And so mainly to reduce the energy consumption of the building, what's important is to focus on the design of the building envelope, which includes the roof, the walls, the windows, and the floors as well. When the facade or the envelope is properly designed, you are able to control heat gains into the building. And also, you are able to allow lights into the building properly. For instance, if you reduce the sizes of your windows, you are going to save more energy in terms of cooling because the windows allow a lot of heat into the building. But remember, when you reduce that size of the window, meaning you're cutting lights off and you have to depend on artificial lighting. Other things like wind catchers, they also, and windows again, allow proper ventilation into the building. Then you reduce the energy used for cooling. Now, to design a building to be energy efficient, the first approach or where you start from is the passive design strategies. What do I mean by passive design strategies? They include things like the glazing. What kind of glazing are you going to use for the window? Should it be a single glazed window, a double glazed window, or a triple glazed window? Other things like the roof, for instance, a highly reflective roof will mean that much of the heat being entering the building will be reflected away. Other things like a wind catcher will allow natural ventilation. There are other technologies like evaporative cooling, indirect radiant cooling, and then also shading on the windows. After reducing the energy use of the building through these applications, what you can do now is integrate photovoltaics like solar power. They can be integrated in different ways in the roofs. They can be integrated on the building facade itself as an element of the building so that you reduce other things like the walls. This PV can come in and replace the walls. Some can be transparent, some can be opaque, depending on the applications. And they can also be used on shadings like on the walls of the building and all. Here's a typical example. We can see some PV on the roof, which serves as a shading for the building. Some opaque on the facade, on the wall here. Some even on the balconies. The glazing there, you can replace it with some PV and also shading on the other ends of the building. So I'm going to present a practical case. A practical case of, is my audio okay?
It's okay, please go ahead.
Okay, I'm going to show a practical case where we apply some of these techniques to reduce the energy use of the building, as well as save costs and the carbon emission throughout the life cycle of the building. So for this case, we looked at things, the design strategies in two aspects. The first one is the building geometry and the envelope characteristics. There we look at things like what type of windows are we going to use? What type of walls are we going to use? Different walls like timber, concrete, some insulated walls. What will be the shape of the building? What kind of roof insulation? What kind of roof material are we going to use? The type of floors and the orientation of the building itself. And are we even going to shade the building or not? Then after that, we also look at the PV. For the photovoltaic, what will be its orientation towards the sun throughout the day? What's going to be the tilt angle of the PV? Because if we do not position it well and it rains, there has to be proper rain that can wash off dust and all of those things. And we also look at the PV area itself because it's related to the cost. A larger PV size may mean a higher cost, but it is probably not needed because a smaller one can suffice the energies of the building. So this is the method that we use. This is something known as parametric design. And right now, a lot of architects and designers are moving towards this approach, where instead of designing the building as a solid form where you can't easily manipulate it, or if there should be any manipulation, then it will imply changing the design largely. But here, we design with a wide range of parameters. Let's say for the length of the building, we set a range between maybe 20 meters to 40 meters, and then the width also 20 meters to 40 meters. So through the application of some algorithms, the software tool or the method is able to generate a wide range of designs like we see in the slides here. So with a single change or a button, you can see a wide range of movements, which is going to have implications on the energy use and then the PV generation as well. The softwares we use here, they're Rhinoceros and Grasshopper, which is publicly available. Then we also look at the energy use of the building. We perform such simulations using Honeybee and Ladybug. There are also plugins which are commercially available. Anyone at all can get them and apply them. Then because there are a wide range of options from this design approach, we have to apply some genetic algorithms to search the design space and generate a wide range of solutions from which the architects together with the clients can choose one. So we take a case study in Ghana. This is a building located in Amasaman, and it's a 4-story residential. Amasaman in Accra. It's a 4-story residential building, and with a total ground floor area of about 1,200 meter square, and we apply some PV integration on the wall with a conversion efficiency of about 15%, and also the rooftop photovoltaic. So with the method showed here, we allow the algorithm to search between the wide design space and give us different solutions. I wouldn't burden you with a building schedule. There's some things. So let's move on to the results quickly. So from the results, we can see that the cooling required for the building is the major culprit of energy consumption, followed by lighting, and then also the equipment use. And we also benchmark these results to be sure that it's right against the actual energy use that we collected from the building, from the receipts from energy paid. Okay. So we also move on now to apply the algorithm to generate different design alternatives. So in this figure here, the green one here shows the initial energy use that we got here against its cost and also the carbon emission. And we apply the algorithm now to generate other alternative design cases. So here are over 5,000 design cases. And because we want to reduce the energy, we want to reduce the cost, and also we want to reduce the greenhouse gas emissions, we select a solution that approaches this end, because at here, this point, the cost, for instance, is approaching zero, and the energy use is also approaching zero, and then the greenhouse emission as well is approaching zero. So we select one of the solutions here, then we expand it further to show you how much energy can be reduced through this approach. So the purple line here shows the base case design, and we can see that from comparing the new design alternative to the base case, the total energy use can be reduced to as high as 36%. And also, we check the PV generation from the roof integration and also the wall integration, which shows it can cover up to 76%. Here, we intentionally limited the PV generation, but in other optimized cases, it can be as high as the building's energy consumption or even higher, and it can be supplied to the grid or other buildings if possible. So this design approach can also be applied to retrofitting as well. Here it's a new design case, but we can try to model the building as built and also try some alternative materials like in the floors and in the walls, in the roof as well, and with implications for energy saving and cost as well. So thank you very much for listening to my presentation.
Right. Thank you very much, Mark. I take very key elements in there to bring out the issues around energy efficiency and ensuring that at least that can be the base case before you add on the renewable energy aspects as well. Nana, I know you have also had a lot of interesting experiences around ensuring that you can have some of these technologies properly deployed. From Mark's presentation, if there was any one question you'd want to ask, I give you the opportunity to ask that question so that Mark would respond to it appropriately in regards of the presentation that's made. So Nana, please go ahead.
I think this is quite interesting just actually this afternoon, we're working on a whole building life cycle project. So we got contracted to work on a whole building life cycle. Okay. And one of the things that we were actually looking at is the move towards net zero, right? Which starts with pretty much the selection of materials, right? And if I'm going to throw a question to you, I'm pretty sure this is even towards your research, but this is also goes towards everyone who works in the green building space. The starting point of improving building efficiency in terms of operational, in terms of embodied energy, embodied carbon, operational carbon, is the material selection. My question for you is, what formed the basis for your selection of materials?
Very well. That's an interesting question. So from your question, the starting point to select a material is to first of all look at its thermal performance. Okay, because a material with a very good thermal performance would improve the operational energy aspects greatly, because that forms about 80% of the building's energy use over its life cycle. Now, when you select that, what happens is that it may end up increasing the embodied energy. And so the approach to use here is to find that trade-off between the embodied aspects of the material, that's its environmental impacts, and also its impacts on the operational aspects. So what we do here is to apply some optimization techniques. So you perform a life cycle and also a life cycle analysis, mainly on the embodied parts, and also for the operational aspects like the energy simulation and the carbon uses. And you kind of find that trade-off between these two aspects, the embodied parts of the material and then its operational parts. Then you have a balance that, oh, this material can improve the energy use of the building greatly, but then it also reduces the embodied aspects. Then you select such a material rather than focusing on just the operational aspects. And at the end, you might end up increasing the embodied energy or carbon emission to about 50% of the operational parts. I'm presently working on something like that, so I'm open for more discussions. I mean, practical examples later.
Can I add something more, Enoch?
Go ahead.
This is quite. It is always quite interesting because from a research perspective, there is that what he's mentioned in terms of the embodied energy, in terms of the life cycle and all that, right? Working in industry and working with materials, a lot of the time, one of the most important things when you run into construction managers is the functionality of the material, right? So it could be reducing energy, it could be reducing carbon, but is it performing in terms of its durability and its function set as the conventional material on the side, right? And this is the trade-off that sometimes it becomes hard when it comes to green buildings and all that. And just to go back to, I think Jibril mentioned that we should be careful in the African context when we're talking about green building. It's not just one attribute that we should use just based on Kenneth's presentation. It's not, we shouldn't just focus on probably one attribute such as ventilation or anything like that. When we talk about green building, you take rating schemes, right? And you realize that there is a whole lot of different issues that you look at in terms of a whole, in terms of a very, in terms of what covers what a green building is. You take Green Star, you find that you're looking at a lot of attributes. You take well building standards, and you realize you're looking at different attributes. And especially, I'm sure if you look at Edge from IFC and all that, you also look at different attributes. So there's the practicality of everything, of the material that you're using for the design, the modeling, and everything, right? To be able to improve the energy efficiency and all that. And then there's the modeling side of things, the embodied energy and all that. So it is easy to look at it from one perspective. It makes the work easier when you look at it from from various angles, in terms of functions and in terms of some of these attributes. So just, yeah.
Right.
Thank you very much. Thank you. One quick comment from me. I like Nana's points very well, because sometimes you may produce something that is unrealistic, but the approach here is to focus on materials that are used practically in Ghana or wherever the region is. For instance, in Ghana, some are switching to this compressed mud clay blocks, and they work efficiently. And we've tried this in modeling and simulations that show that it reduces the embodied energy particularly significantly, because very little cement, which has a very high impact, is used there. But then also this material performs very well in the operational aspect. So it's very good to look at design solutions that are practical, design solutions that can be applied in the context looked at. Thank you very much.
Well, thank you to you all. This always happens when you are getting right deep into the middle of the issues and it's becoming more interesting, then the time bells are sounding. Technically, we have about 4 minutes to wrap up this session so that we can have the next session starting up. We haven't gone so deep into the questions that have been put into the chat, but there was one that was earlier posted. So I just want to bring that up with regards to the usual trends now about environmental impact and renewable energy. So what I'll do is to help with the 30 seconds closeout that each and every one of the speakers would have, I want you to pick one area you'd want to speak to and then close out with that. So Jibril, that particular question is for you with regards to the trends within environmental concerns and management and then renewable energy. Kenneth, you would go subsequently with your wrap up as well. Nana would go, Mark would go, Nana would go, then I'd come around. And before that, I would also state that it's very, very, very unfortunate that we don't have any ladies on the panel. That's my initial comment. And I thought to say it out here, but I'll say that as it is. Our ladies are cheering us on as we move forward. So let's say it's something that we're patting ourselves in this particular case. But the guys on here have done a great job. And personally, as someone who's been pushing for a lot of gender advocacy and integration, I take it that today is just the face of it where you have all the men. But we'll get the ladies also talking in the subsequent one. So I'll leave you, Jibril, to have your closing remarks. Kenneth, and Mark.
That's fine. Thank you so much. It was very nice listening to everybody speak. In closing, regarding manufacturing, we always had these concerns. What we should always bear in mind is this. Energy generation contributes to about 25% of the greenhouse gas emission globally. Manufacturing do about 15 to 18%, okay? Now, when we talk about renewable energy, first of all, our focus is on decarbonizing energy generation, first of all. Now, on manufacturing and industry, those are the sectors that actually, you're correct, that manufacture all these materials we need in producing the panels, the battery, the inverters. But bear in mind, even for oil and gas, it also takes a lot of carbon to manufacture the gas turbine, there are a lot of oil spill, all those things, gas flaring that also happens. But in the past 5 years, 10 years that I'm aware of, there's been a lot of research in the aspect of carbon capture as well as hydrogen, because we need to move very quickly. So a lot of innovations are going into that technology as well to absorb the carbon that has been emitted to the atmosphere. We have that. Also, we also have hydrogen trying to compete with gas and coal in terms of the intensity. Now, also for me, in closing, is the net metering and smart grid infrastructure. For me, that's the future. If you look at all the global NDC targets under the Paris Agreement, you'll realize that they're quite ambitious, but a lot of them are still skewed towards centralizing power, which I don't think is going to happen. A lot of the stranded assets in America, in Europe, on coal, nuclear, all these things would expire very soon. And a lot of people are understanding the fact that they can also raise their own capital to install solar and then embed that to the grid, because the grid already has the distribution infrastructure that is needed to distribute this thing to everybody. So I see a more of decentralization toward distribution of power for the next 10, 20, 50 years, okay, for us to decarbonize that space. And for One Watt Solar, that is what we're also focusing on. By Q1 next year, we'll be launching a new product. They are working in collaboration with the utility grid on how they can leverage on our software built on blockchain so that we can share data, and then they can know when we can embed energy to them, and then they can then effectively know how to also manage energy distribution during the evening when there's no solar. So I will just end there, that the future is bright. There's need for a lot of more innovation and research, but also action very, very quickly. Thank you so much.
All right, thank you very much. Kenneth, you are muted. Please unmute.
Sorry about that. Yeah, so I'll briefly want to provide a sort of an answer in relation to the question mark posed, or the observation mark made, in relation to the fact that in Ghana, it appears that there is very little attention paid to design of buildings. And my question is, why is it so? Particularly because, I mean, from research, we know that sustainable buildings or green buildings, for example, could be a sort of an economic strategy to help save cost. So through lower energy bills, green buildings will become more attractive. But then why are people not ensuring that their designs are sustainable? And this is where I believe the idea of educating people about what green buildings are and what the technologies are will be useful. And so I just want to say that in as much as there's a need for new innovations in the RE space and even in the green building space, it is important that we also spend time educating the end users of these technologies, because ultimately they are the people who are going to demand these technologies. And if they are not aware of these things and they do not understand them, then that could affect their demand for these technologies. Thank you.
Thank you, Ken. Nana.
Thank you, Enoch. Really, my closing remark is around government support for the space. And for us to get from where we are now to where we want to be, I think it's very important that the government supports the private sector and supports the green building sector in terms of funding, in terms of policy, in terms of training and all that. It is very important. The only way some of these countries have been able to do it is the support that they've gotten from the various, from the government. and from policies and all that. So for us to, when we talk about green buildings and where we're going and all that, we're looking towards a space where embodied energy is close between 74 to 100%, right? Which takes out the operational energy, which is the largest contributor to carbon emissions and all that. The only way to get there will be with government support and industry, innovation, private sector also encouraging people to buy and develop materials that will inform, that will help the industry. So
right.
Yeah, from my end, a lot of support and a lot of synergy is very much important.
Right. Thank you.
That's those are my closing remarks, and I'll just pass it on.
Mark is all yours.
Okay, thank you very much. I think, particularly for the case of Ghana, a way to go is to have energy efficiency policies. Most of these developed nations that have been able to achieve such advances in energy efficiency all have building codes that are tailored to the needs of that region. So it's become very important to have some energy efficiency policy, some green building assessment scheme tailored to suit Ghana. And that will be a good starting point for an architect or a designer to have some reference to improve the energy performance of the building. And so if we put a lot of efforts, it could be from the private sector, it could be from the government, to develop some benchmark, some benchmark for designing general for renewable energy applications, that will go well to improve the energy efficiency and renewable energy applications in Ghana. Thank you.
Right, thank you very much. So from my side, first and foremost, I'd like to further congratulate everybody who's been working in this space. It's a lot of huge work we're doing, and we all need to sort of band together, share ideas, share knowledge. And so this particular Ghana Green Building Summit offers this possibility of doing that. And I've been happy that at this morning session, which is the Game Changers, we've had Dr. Jibril Adeoje, who is a co-founder and CEO of 1 Watt Solar Nigeria, being on the panel. We've had Dr. Nana Bote Ayi, who is the Green Global Tag EPD Program Manager in Australia, joining us. We've had Mark Ansa, who is in the Renewable Energy Research Group in Hong Kong, also joining us. And we've had Kenneth Kiame Donko, who is the real estate economist and lecturer in the Development Finance and Sustainability Unit at KNSD, also joining us. My name is Enoch Yeboah Ejepong. I am an engineering consultant and a management consultant. I'm the co-founder of the Renewable Energy Association of Ghana, and have worked in the renewable energy space and the energy space and policy aspects in Ghana for quite a while now. I would close my remarks by also indicating and noting that the work that we're doing is very important. It's important because we know that energy is a key attribute to ensure we have productive use of productive livelihoods, economic empowerment, and a host of other social unrest being addressed when you have these energy inputs. I have been privileged to have partnered this particular program to go on, and we would continue to do that, knowing that there are amazing other people also doing things out there. And so I doff my hat whilst congratulating and thanking the panel to also all the other partners who have been working in this space. I know there are the GIZs out there, there's the Danish support, there's the Danish companies, there are the USAIDs, there's the Millennium Challenge Corporation, the Millennium Development Authority, and a host of others, individuals, private sector practitioners, actors, and all that. What I'd also want to say to the general public is that if you'd want to have an experience of what renewable energy and energy efficiency is, please contact us at the Renewable Energy Authority. Sorry, well, I've already talked about the Renewable Energy Authority. Why I mentioned that is that there's the Renewable Energy Authority that's supposed to be set out from the RE Act. And that's one of the things coming up. But first and foremost, let me just backtrack. Please contact us at the Renewable Energy Association of Ghana, where we are planning a lot of these environmental tours and trips, particularly to a lot of these sites where there are interesting renewable energy installations. And today, as we are all, okay, not all, as some of us are in the green building at the CalBank head office, I'd want to also acknowledge CalBank for being a good support and partner to this program. We're going to take a break, and when we come back, we're going to go into the next session, which will be focused on reimagining facility management in a digital age. And then we'll talk about a lot of things that have to do with that. So first and foremost, I want to also thank you all for your attention and to say, let's have a 5 minutes break. Please grab coffee, take a health break, and come join the session shortly. Thank you all and see you soon.
Thank you. Bye.